DNP3 Basics, Lesson 10, Class Polls. Most of the presentation on objects so far has talked about individual input and output objects. While outstations use the input objects to report point data to the master, most master read requests do not explicitly ask for these objects. They can, but they typically do not. They ask for what is called class data and issue what are called class data polls. Remember, we talked about four classes. Class 0 contains the static, current values, and states of all input points. Classes 1, 2, and 3, as a combined set, contain all events. The master can get the static data for all points by issuing a read for class 0 data. All events can be obtained by reading classes 1, 2, and 3. From here on, we will talk about points assigned to classes 0, 1, 2, or 3. For these, a read of class 0 data returns value state information for all points assigned to class 0, 1, 2, or 3, and only those points. That is, the static value for a point assigned to class 1, 2, or 3 implicitly belongs in class 0. The events are in class 1, 2, or 3, but the static values are in class 0. If a point generates events, it must be assigned to class 1, 2, or 3. There is no such thing as an event that cannot be accessed by a class 1, 2, 3 poll. If a point does not generate events, it may be assigned to class 0 or to no class. We will talk about no class later in this lesson. Object group 60 is used to read poll class data. This object can appear in a request only. A class poll can request data from one, all, or any subset of the four classes. The response to a class poll returns a series of object headers for each object in any of the requested classes. The class object does not appear in a response. Like any other object, a message reading class data uses an object group, variation, qualifier, and range. The object group is 60. The variation is one more than the class. So 1 is used to read class 0 data, 2 for class 1 data, 3 for class 2, and 4 for class 3. A read of variation 0 is not allowed, since variation 0 for most objects leaves the choice of a variation up to the outstation. This does not make sense for class data polls. The qualifier and range is usually a qualifier of 6, which is used to read all points. This is required for class 0 data and very common for class 1, 2, and 3 data. The other choice is a qualifier of 7 or 8 that includes a range field, which is a count. The count specifies the maximum number of events to read. When a read for multiple event classes uses a quantity qualifier for one class, it implicitly applies to the total of events from all classes. For example, a read of 20 events from class 1, 20 from class 2, and 20 from class 3 returns a maximum of 20 events total. even if each class has individually 20 or more events. Here we have a few examples of the application layer octet string for reading various common class data sequences. The first one has an application header of C0 and a function code of 1 to read. The group in all cases is 3C hex, which is 60 decimal, which is class data. And since this first example is to read only class 0 data, we have variation 1, which specifies class 0, and qualifier 6 for all points. The second example is a read of class 1, 2, 3, and 0 data in that order, which is typically called an integrity poll since it gets everything out of the outstation. Again, the control octet in the application header is C0, function code 1 to read. The first group is hex 3C, which is 60 class data, variation 2 for class 1 data, qualifier 6 for all points. This is followed by similar headers for class 2 data, class 3 data, and finally class 0 data at the end. The final example is used to read up to 20 events from the outstation. The same application header and function code is used. The first object header is for group 3C, which is 60 class data again. Variation 2, which is class 1. Qualifier 7, which specifies a count of points, and a range of 20, which says I can read up to 20 events. This is followed by similar headers for class 2 and class 3 data, each specifying a maximum of 20 points or events. So the total response from the outstation can have from 0 to 20 events, but no more. Okay, now we're going to talk about a couple of important things to note about class data polls. The first is if a system processes events, and most do, there should never be a request for just class 0 data. Why? Let's assume some binary points state is 0. A master issues a request for class 0 data. As the request is going to the outstation, the points state changes to 1. This inserts an event in the outstation's event queue. The class 0 read response contains the current state of the point, which is 1. This does not get rid of the event in the outstation's buffer. When the master later issues an event poll, it gets an event reporting the points change from 0 to 1. This might be confusing since the state was already 1. How can a point change to 1 when it was already 1? To prevent this, all read requests that include class 0 should also include classes 1, 2, and 3. And 0 should be the last in the list. So the request should be 1, 2, 3, 0, as was shown in the prior examples. The outstation should process this by returning all events and then all static data. Also, the set of static data returned should represent the states and values as they existed when the read was received, or at least the states and values that are consistent with the set of events returned. And the second point refers to As we previously stated, there are 4 data classes, 0, 1, 2, and 3. But there's also a 5th possibility called no class. Most input points reported by an outstation send data obtained or calculated from field inputs. Sometimes some binary or analog inputs report parametric data, which typically never changes or does not need to be reported when it does. Let's assume, for example, that some large outstation has 288 analog inputs. 256 of these contain real-time data, and the other 32 contain parameters. If all analogs were always reported in response to a class 0 poll, this would cause the 32 parameter points to be reported every time, wasting a lot of unnecessary bandwidth. Being reported once is enough. Such an outstation can assign the last 32 analog inputs, the parameters, to no class. Points assigned to no class are not returned in a class 0 data poll and never generate events. However, their values can be obtained by issuing an explicit read for the analog input object group, using a qualifier specifying a start-stop range that overlaps their point indices. That is, no class is used as a place to put points that the master does not want to get very often. Points are assigned to a class or to no class by device configuration, not by the protocol. So that's the end of another lesson, this one a little shorter than the prior one. What did we learn here? 1. Most masters use class data polls to read input data from outstations. Class 0 is used to read static data. Classes 1, 2, and 3 are used to read event data. There is no protocol rule defining assignment of points to a specific event class. If a point returns events, it must be assigned to class 1, 2, or 3. Class 0 reports current states and values for all input points in the outstation assigned to class 0, 1, 2, or 3. Class 0 does not report data for points assigned to no class. A read of class 0 data should never be used without including class 1, 2, and 3 data in the same request, with class 0 the final class in the list. Class 0 data can only be read with the all qualifier. Classes 1, 2, and 3 data can be read with the all qualifier or with a count qualifier setting the maximum number of events that may be returned.